AP Calculus, Section 3.9, Derivatives of the Exponential Functions, page 1. We're starting here wanting to find the derivative of e to the x. We don't know the derivative of e to the x. I can't rearrange this. That would introduce logs, so we're going to have to start with the limit definition of a derivative. Do you recall that limit definition of a derivative is f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h, and then subbing in this function e to the x in here, we'll have the limit as h approaches 0 of e to the x plus h minus e to the x all over h. Rewriting this e to the x plus h, we can say that e to the x plus h is e to the x times e to the h minus e to the x all over h, and then factoring out an e to the x, all over h, and then we can separate this limit over this multiplication right here. So we'll have the limit as h approaches 0 of e to the x times the limit as h approaches 0 of e to the h minus 1 all over h. This first limit right here, there are no h's in here, so this e to the x is not dependent on h getting closer to 0. This limit then is just e to the x times this limit over here. We don't know what that limit is. It's not something we've memorized. We can't factor. We can, however, go to a calculator, and I've graphed e to the x minus 1 all over x. And when we look at that graph from -5 to 5 in the x direction, -5 to 5 in the y direction, we see here as x gets close to 0, which is like h getting close to 0 over here on e to the h minus 1, we see that that function gets close to 1. This limit then is 1, and we have e to the x. All of this says, oh, I should write it this way, the derivative of e to the x is e to the x. I love this function because it's the only function whose derivative is exactly itself. This is all nice and pretty for just y equals e to the x, but if we happen to have e to the something else, we can expand this a little bit further and say the derivative of e to the u is e to the u times the derivative of the u. And you should recognize that as telling you to use the chain rule. Yes, you need to memorize this. All right, let's do a couple of problems to apply that new derivative rule. If we have f of x equals e to the 3x, I want you to find f prime of x. This 3x is the u. Excuse me. When we find the derivative, f prime, that's e to the u, so e to the 3x times the derivative of the u, which is just 3. And then rewriting that so this looks nice, we have 3e to the 3x. That's it. That's the derivative. It does get a tad bit harder when we look at this one over here. If we want to find the derivative, and plugging through right away, you're going to have to see that this is a product rule right here with x squared times e to the x, and another product right over here at x times e to the x. So finding that derivative, first x squared times the derivative of the second, which is e to the x, plus the second e to the x times the derivative of the first, 2x. That is the first product rule, minus, now this second product rule, make sure you use parentheses here to subtract both parts of that product rule here. So first, x times the derivative of the second, which is e to the x, plus the second e to the x times the derivative of the first, which is 1. Cleaning this up a bit, we'll have x squared e to the x plus 2x e to the x minus x e to the x minus an e to the x when we distribute that minus sign through. These two right here, 2x e to the x and x e to the x, those are like terms. We can combine those and we'll get x squared e to the x plus an x e to the x minus e to the x. And the last step here is to factor out that e to the x that's common in all three terms. And we have that f prime of x is e to the x times the quantity x squared plus x minus 1. Alright, this formula is beautiful when we have an e to a function up here. So the base of that exponent is e, the number e, 2.718 approximately. What happens if we have different bases? So a 2 to the x or a 3 to the x, something like that. In order to do that, we're going to have to remember this formula from pre-calculus. A to the x equals e to the ln a to the x. If you remember that formula, awesome. If you don't, just go with this for now. And we're going to have to do some manipulating here before we do a derivative. And the first thing is that let's take this log expression right here, this natural log of a to the x, and let's take that exponent, that x that's right up here, and we can pull that down in front. Remember that leaping exponent idea? So that now we have something that looks like this. A to the x equals e to the x ln a. Alright, now before we do another step, I do want to refresh your memory. This a is a constant. A is a constant. So then ln a is also a constant. For example, if a was 2, the base of the exponent is 2, then ln 2 is also a constant. That little piece of information is going to become very important in the next couple of minutes here. Let's do a derivative now. So we'll have the derivative of a to the x equals the derivative of e to the x ln a. This left side, that's what we're trying to figure out. The derivative of an a to the x. So we're going to leave that alone. On the right side, we know how to do this now. We're finding the derivative of an e to the something. To do that derivative, it is e to the something, so e to the x ln a, times the derivative of this mess right up here. The derivative of that x ln a, ooh, that's where this comes important. Ln a is a constant. So this is like saying x times 2. The derivative of x times 2 would just be a 2. So the derivative of x times ln a is just ln A. All right, now we're going to do some rearranging again. And this time I'm going to go backwards with this x right here. I'm going to pull it back up as an exponent on that log. So we'll have e to the ln a to the x times ln A. And then right back up here at our beginning line, this piece right here, that is a to the x. A to the x is e to the ln A to the x. That's a to the x times ln A. Oh, look at that. The derivative of a to the x is a to the x times ln A. Beautiful. Take it one step further so that we can have an a to the u. And the derivative of a to the u is a to the u times ln A times the derivative of the u. Yes, you need to memorize this. Okay, we will not ask you to go through this derivation of where that formula came from. That's why I kind of just blew over this formula right here. So if you didn't quite get that from pre-calc, that's okay, because the long and short of it is that you need to know this formula. You have to be able to do the derivative of an a to the u situation. Thank you. Stay tuned for page 2.